Yeah, I'm Cecilie Miljeteig. I'm a researcher at Group Task Force Salmon Lice at NTNU. And today I'll present one of our projects, Dyplus. It's a project where we have been looking at the effect of submerged farming on the lice levels and the fish welfare and growth. And also we have been looking at salmon lice biology and development and behavior in lab experiments. This project is financed by FHF, and our project partners are Sinkaberg, Emerson Fisk and Lerøy Midt. So today I'll focus on these data that are production data from submerged farms. And these are also available in Cecilie Høvig's master thesis, available on NTNU Open. And we're also approaching the end of this project in September 25. So we will also compile a final report very soon. There's a lot of echo. Is it something you can do something about? I hear myself twice. It's a bit... So why submerged farming? Why does that work? So we have the sea and a traditional net pen, and we also know that the infective salmon lice are staying in the top meters of the sea, and this is called the lice belt. So the principle in submerged farming is to lower the whole pen below this lice belt, and then less salmon lice will find and infest the fish. So this is the same principle used in other barrier technologies like lice skirts and snorkel pens. This is of course very simplified. There are no physical barriers, and some salmon lice will go below. This depends on their local hydrodynamics, how much mixing you have in the water, and how deep it goes. So the use of submerged farming has had an explosive growth. I don't have any numbers, but it started growing, increasing in 2023. So it's not been very long. And for many, they are still on their first deployment using this technology. And it's not easy to just lower the production to 25 meters below the sea surface. There's also a lot of requirements for the location and the technology. So I'll just go through a short list quickly, because some of them are important for when we look at the production data a bit later. So some examples of things you need is you have to have an air dome. The salmon needs to be able to fill the swimming bladder. There's an example for what it looks like. You need good environmental conditions also in your deeper water, in particular oxygen. You need to have sufficient depth at the locality, and you need to know the hydrodynamics. How much mixing do you have through the year? You can't see the fish anymore, so you need to be able to monitor it. You need to have automatic lice counters, and you need welfare monitoring using cameras. You need to feed it wet, and to run all of this, including lights, you need stable access to electricity. Okay, back to the project. So it's new technology, explosive growth, and the experience shows that it works really well, but we lack summarized knowledge on this full-scale production. So this is what we're trying to give here. And we did this by collecting data from our project partners on full-scale commercial production on pen level. So all the sites were in production area 6 and 7, that's here in mid-Norway. And we paired each location with submerged farming with a nearby location with historically similar conditions. And that's a reference locality. We have spring and autumn deployments, and deployments from 21 to 24. The data we collected were temperature, oxygen, lice counts and delicing treatments, growth, production time, slaughter weight, quality classification, some welfare indicator information, and mortality. So this table is quite compact. I just want to explain it a bit. So the blue lines are submerged farms, and the orange are the the reference localities in the surface, and they are paired. So, I don't think the lace is working, but the top, if you see D1S22, is paired with R1S22, and the S is for spring deployment, A is for autumn, and the year at the end is the year it was deployed. The ones marked in gray are a bit incomplete data because they weren't finished at the time of analysis. So first, temperature and oxygen. We'll just have a quick look with 2 examples. We see that the temperatures are higher in the surface farms in summer, indicate here, and higher in the submerged farms in winter. But the average temperature in this cutout table here is a little bit higher through the deployment in the surface farms, 9.3 versus 8.7. And we also see slightly lower oxygen levels in the submerged farms, but the 83 versus 87, but they are more stable, and we don't get these sudden dips in the oxygen that we see in the orange lines. So for the lice counts, I will be focusing on the most recent years as they are more relevant and also showing the highest infestation risk, mainly due to the period of marine heat wave last year. So in all of them, we can see that there are lice present in the submerged cages. There is infestation happening, and it's not just from going up and down, it's also coming down there. But we also see a much lower number of delousing treatments required in the submerged cages. So here we have an average of 0.9 delousing treatments per pen in the submerged and 7.6 in the surface. So here's another example. So it looks like there's a lot of delousings here, but we also have to look at this list here, which says how many pens were deloused, and usually here it's 1 or 2, whereas over here in the surface locality, it is most of them or all of them. And we see the same here. There's a lower number of delousing treatments required, 1.5 versus 12.3. And this is the location and deployment with the highest number of delousings from both the submerged and the surface locality. Okay, one last example. Here we had 1.3 delousings per pen in the submerged and 4.4 at the reference locality. So at this site, it was maybe the closest between the two, smallest difference. But so we can't avoid the salmon lice completely, and with the high infestation pressure, such as the summer 24, there's also increased infestation pressure in the submerged cages, leading to the need to perform delousing treatments. But if we look at the numbers, there they are, it's quite a big difference. It's 1/10, 0.6 versus 6.1 delousing treatments. And even if we look at the worst ones in the submerged, they are, even there, the submerged ones are doing better than the surface localities. Over to growth. We can see that the estimated growth is quite similar between the two types of farming, with perhaps slightly higher growth in the surface farms. So the closed circles here are indicating the individual pens, and the open circles are individual, and the closed circles are the averages. So we can see at the at the end, the slaughter weight is quite similar between the surface and the submerged, but it does look like it takes a bit longer in the submerged farms to reach the same weight. This could also be due to the reduced need to accelerate the slaughter of pen due to high lice levels. For example, if it is a lot of lice in one pen, you would take it out early to not have to delouse. But if we look at the overview, we can see that overall, the slaughter weight is a bit higher in the submerged farms, 5.8 versus 5.1. And we also see that the production time is about 5 weeks longer in the submerged farms. However, if we just look at the autumn deployments, we can see that the difference between submerged and surface is smaller. It's either the same or up to 3 weeks difference, 1, 3, and 0. So if we look at superior classification here, we see that this is also higher for the submerged cages, 94% versus 84%. Mortality. The accumulated mortality in each pen is variable between the deployments. So it can look like this, with no specific incidents and relatively low mortality throughout the production. Or it can look like this, with a lot more variation. So just note that the scale is different here. So this one over here is scaled to 40% and this one to 20%, so the difference is not as big as it looks. Anyway, this is the deployment with the highest number of delousing treatments. The one I showed before, with 12.12 and 1.5. The D2 and R2 deployed autumn 23. So with that many delousing treatments, we would expect a higher mortality in the surface locality, but the average mortality here is only 5%. But in the submerged cage, we see several episodes here where we have an increase. Part of it is gradual and some of it is sudden in accumulated mortality. And at the end of the production, the accumulated mortality is at 13%. So this is the result of a combination of things. There's storms, there's instability in power supply, causing blinking of lights, which causes panic reactions, and you have injured fish. And there's illness outbreaks, and also a couple of delousing treatments. But nothing compared to this one, where there was 12. So it's more complicated than that. If we just remove the delousing, we will have better mortality. It's not that simple. So these were maybe two extreme examples. But if we look at the overview here, we have about 1% lower mortality in the surface compared to the submerged cages, in spite of many more delousing treatments. So I do hope that this is something that can improve over time, because it's a new technology, and that this will improve as the technology develops and the farmers develop better routines, and the importance of stable power supply is implemented. Yeah, the welfare, I'm not going into this because it's very difficult to compare, and especially quickly, but because it's done differently between the companies, and also in the surface farms you can see the fish and have access to it, and in the submerged you don't. So I will just say that the main issues we see in the submerged cages is fin damage, scale loss, and some wounds, snout wounds and body wounds, often from panic reactions when you get problems with the power and blinking. Yes, quick summary. So it's a new technology, there's new challenges. The salmon lice infestations does occur also in the submerged cages, but we have a lot less delousing treatments, 1/10. It's a big difference. We have a higher slaughter weight, longer production time, and a higher superior classification in the submerged cages. And the deployment time may matter. Maybe this should be looked more into. There's also challenges with mortality. They are slightly higher in the submerged farms, and it's high variation, so there should be room for improvement here. Yes, thank you.